Welcome to your own channel of Right Funda. Here is a very interesting problem from rotational motion. Let's go by the wording of the problem. A small rubber ball of radius R is thrown against a rough floor with a velocity of magnitude V0 and an angular velocity of magnitude omega naught. It is observed that the ball bounces A to B, then from B to A, and then from A to B, and so on. Assuming perfectly elastic impact, determine the required magnitude of omega naught in terms of V naught and R, and also the time period of oscillation and coefficient of friction between the ball and the floor. So what the question is saying that there is a ball, and suppose this ball is thrown toward the wall, toward the floor like this. It is thrown like this, and it strikes, and it again come back like this and fall here. It is again made a collision here, again come like this. This keep on repeating like this. It keep on repeating like this. So having some velocity and also omega over here. So that's why it is happening like this. So we need to calculate if this is to and fro from A to B, B to A to B, continuously it is colliding, and the collision is assumed to be elastic collision, perfectly elastic impact. We need to calculate what must be the relation between this velocity of the center mass of the sphere and the angular velocity of the sphere, and also we need to calculate the mu between the sphere and the floor and the time period of oscillation to be calculated. Now you have understood the question. Now you can pause the video and start solving the problem. Once you put your sufficient number of attempts, after that, either you got it the answer or won't get the answer, again you can resume the video and you can see the solutions. Okay, I will be discussing the solution right now. Let's see what will happen. So to solve this problem, we'll be getting some idea. We'll make the strategy of solving the problem, how to solve this problem, how to think, and how to get the idea of solving the problem. Let's discuss. What are things are given? Number one, it is given that it is an elastic impact. First thing is that elastic collision. Elastic collision means the kinetic energy has to be conserved. There is no loss of energy at the time of due to the impact. Okay, just before the collision, whatever the energy was their kinetic energy form, that will be the kinetic energy after the collision also. Second thing that it is continuously colliding. Here it is continuously colliding. Okay. So what can be done is that there is a time period also there. It is saying the time period there. So time taken from going to here to the periodic motion. Number two is saying the periodic motion. So the time taken from going to A to B is same as the going from B to A. It is A to B, and it is happening like this. Time period is same. Okay, these two things we got. Second is the rough surface is there. Another is that's why coefficient of friction action is given the rough surface also. So what must be happening? Number one thing. So this bell body having some velocity like this V0, it has some horizontal velocity and it is having some vertical component of velocity downward. Just after the collision, it must be, there will be velocity must be reverse and some vertical will be there and some horizontal will be there. Now what is happening that it is taking the time, and time taken to go from here to here depend upon this vertical component velocity. Time taken to go from here to here, that depends upon this vertical component of velocity. As the time period is same, is a time period maintaining a periodic motion, then definitely this vertical component of motion here and here must be same. Again it is coming the same, and in every subsequent collision also this must be same. The vertical component is only the magnitude will keep on changing, but direction will keep on changing, but magnitude will remain same. Second thing that it is going from A to B and B to A means the range is constant. Going from here to here and going from here to here. So horizontal, and the range depend upon what? Horizontal component velocity into time of flight. So time of flight we have discussed the first part is that it must be constant. So this horizontal component velocity also must be same at here and here, and every successive collision also horizontal component again becoming the same thing as the previous one. Okay, so these are two things we got. So what happens is neither the vertical component is changing due to collision nor the horizontal component is changing, because only the speed was same but direction is changing, and total kinetic energy constant. So if the linear speed, velocity of center mass is not changing and the total kinetic is conserved, and we know that kinetic in the body equal to half m VCM square plus half IC omega square. So VCM is not changing due to collision. So speed of the center of mass is not changing, so definitely angular speed also must not be changing. So whatever the omega over there, just after the collision, it must be same omega but in the reverse direction. So that will be coming like this, and same periodic process will be keep on continuing. These are the things we got an idea. And let's see, first draw the free body diagram. What is happening in the things case? First we have to start with the free body diagram. So let's take the ball. Suppose this is my ball here, and what are the forces that will be acting at the time of collision, during collision? And during collision we basically discuss about the impulsive forces. Okay, gravity will be acting on this, but gravity will not be impulsive force, but definitely force will be acting here at the time of collision. One normal direction will act, and there's a very huge force at the time of the impulsive force. Second thing, this body, if you see, it is saying that body is going having some velocity like this and also having some omega like this. So this body having some horizontal velocity like this and omega, v and r omega both are same direction. So this point velocity, net velocity in this direction. So it will be have a tendency to slide, or it will be velocity and horizontal, the surface velocity 0 there. So definitely on this there will be a friction force will act in the opposite direction, and this friction force must be kinetic in nature. So F must be equal to mu. The net velocity of this is due to velocity of center of mass, also a one component like this, and r omega also in this direction. So net velocity in this direction, so friction force will act, and this is a kinetic friction will be acting. These are two forces. Of course, mg is acting, but mg is not an impulsive force. So just before collision and just after collision, we can simply neglect as compared to these huge forces, these impulsive forces, we can neglect this. Okay, their contribution will be negligible contribution will be there. Okay. So what is happening? What is the purpose of this normal direction? The normal direction will give an impulse, and that impulse will change the y component velocity. So y component velocity was something like this, and it become like this. So before collision, this velocity was in the y directions was v naught sine 60 over there, and this become v naught again sine 60 in the opposite direction. So it was v naught sine 60 minus j cap and v naught cos sine 60 j cap. So what is the change in velocity there? V naught sine 60 minus v naught sine 60 minus j cap. So minus minus plus, and so delta v, or change in momentum, m into 2 v naught sine 60. Okay. Similarly, this force was there, and this force also, it is having some horizontal velocity there, and this horizontal velocity become like this. So again, this will giving an impulse in the rightward directions, and then change the velocity from minus vx horizontal component velocity to same value in the plus vx direction, because this component is not changing. Also, this will produce some torque. Will produce the torque. The force, the friction will produce some torque about the center of mass of the sphere. Okay. So three things are there. There are two linear impulse equations we can write. One in the y direction, one in the x direction, and one in the torque in the k cap directions. Okay. So let's write the equation. What can be written? First thing we said the n dt integration. So with the n dt integration is equal to the change in momentum. Change in momentum m v naught sine 60 was minus j cap was there, and become m v naught sine 60 j cap. So change is equal to 2 m v naught minus minus plus 2 m v naught sine 60. This is how we call the equation number 1. Okay. Then another, the force, friction force is also producing some impulse, and first let's calculate this one, and root 3 by 2 if I substitute, then equal to this, and I suppose this I call that question number 1. Okay. And f dt integration we can write friction force ka impulse, so that will be equal to f dt integral 2 m v naught cos 60, because its momentum velocity was, because making a 60-degree angle with the horizontal, so this was equal to 60, cos 60 was there, minus cos 60 v naught cos 60 plus v naught cos 60. So change in momentum is equal to 2 m v naught cos 60, and cos 60 is equal to half. So I have the half and 2 cancelled, and we got mu and dt integration equal to 2 m v naught. This is equation number 2. So two equations we got. Let's put in a border for this one. Put the border for this. Okay. So this is the one equation I got, and another equation is this one we got. Okay. So these are two equations we obtained for the n dt integration and mu and dt integration. Now, if we write a torque equation, friction force will produce some torque about this. So if I write this tau dt integration equal to change in angular momentum. What is angular? I omega naught. So equal to minus k cap was there. Directions were like this, minus k cap, and after collision it become k cap direction here. So I omega naught minus I omega naught equal to 2 I omega naught is that. Okay. So we have written this torque dt integration. So torque is nothing but the what? R cross F. R cross F dt integration. Momentum is the solid spread about the center mass equal to 2 by 5 mr square into omega naught. This equation we got. And this F is nothing but mu n because the kinetic friction is acting. So if I put these values, then we got that R, mu and dt integration equal to 4 by 5 mr square omega naught. Or if this and dt integration from this, you see this mu and dt integration from equation number 2, I can get the mu and dt integration. So if I take this mu and dt integration and substitute here is equal to m v naught, then we got the equations, we can obtain the equations R into m v naught is equal to 4 by 5 m r square omega naught. Okay, so from this I can simplify this equation. This R and this R get cancelled, this m and get cancelled, and omega naught from this we can obtain to be satisfy this equation, so that it will be reversed and the kinetic energy will conserve. So we got this equation omega naught must be equal to 5 by 4 v naught by r. 5 by 4 v naught by r is the equation, the relation between v naught and omega. Then only it is possible that the vertical component velocity get reversed, horizontal component velocity reversed, and the omega also get reversed. Then only this is possible that the ball will be moving to and fro from here to here without change of energy, without change of kinetic energy, and the time period will be same and the range will be same in each subsequent collision. So this relation, that first thing is asking that determine the magnitude of omega naught in terms of v naught. This one part we obtain. Second, they also find the time period oscillation and the coefficient of friction. So let's calculate first the coefficient of friction. So what is the coefficient of friction will be there? We have obtained equation number 1 and equation number 2. If you divide the equation number 2 by equation number 1, from this, if I divide this one, then I can get the mu is equal to this divided by this, equation number 1 by 3 is equal to 1 by root 3. Mu is equal to 1 by root 3 that we obtain. So this is possible only if this, what are the angle 60 degree given, according to 60 degree angle, mu, this dividing by equation 2 by 1, we got the mu must be equal to 1 by root 3. And third equation is in the find the time period of oscillation, and we know the time period that depend upon the y component velocity. And the y component velocity initially time period equal to 2 into initial y component velocity into g. So what is the y component velocity? That here it was equal to minus v naught sine 60 was there, it become plus v naught sine 60, and this component velocity will go again, will reach this point till the time it is g not 0, it will be going the ascending, and it will be descending from the center mass velocity in the y directions. On the vertical direction we can calculate, and vertical velocity is equal to, we can say the v naught into cos sine 60 root 3 by 2. This 2 and 2 we can cancel this 2, and we obtain the time period of to and fro motions, the periodic motion that will be happening is equal to root 3 v naught by. So this three result we obtain. If this ball is thrown with making a 60 degree angle, and it is to and fro, it is making elastic collision, and it is again moving and from A to B, B to A to B, it is happening without loss of energy, and if both the angles are same, the time periods is remain constant, range remain constant, then we obtain, this is only possible for the 60 degree projection, it is only possible that mu must be equal to 1 by root 3, and the velocity and omega should be directed such that if the velocity is like this, the omega must be like this, and their relation between v and omega, relation initial must be equal to omega naught must be equal to 5 by 4 v naught by r for the sphere case, and in this case the time period of the periodic motion from A to B and B to A will be equal to, going from this one round is equal to this one. So time taken to go from here to here is called this is called the time taken to go from here to here, we've calculated equal to t. And what is the periodic motion? The time period of oscillation, saying that's one complete, this is not one complete, not over, going and coming, this will be equal to one complete oscillation will be there. So in that case, this time, to double of this time will be my time period of oscillation. The double what I obtain is double will be my time period of oscillation. So I call the time period of the periodic motion, because there is a half only going from here to here is there. So time period will be equal to root 3 v naught by c, with the going from here to here and again coming from this one cycle over, again second cycle over repeated. This we obtain the time period of periodic motion. Okay, so this we obtain, and hope you have enjoyed the solutions. If you like the solution, just like the video and in the YouTube, and Subscribe if you have not subscribed yet, subscribe, and so that you will be get notified as well as soon as a new video is uploaded.